right, welcome back. So last time, we kind of dipped our toes into the world of threads. Today, we're jumping all the way in. We're going to follow the entire life story of a single Java thread, right from birth all the way to, well, the end of its job. You ever stop and think about how your computer is like a master multitasker? It's downloading a huge file, you've got music blasting, and you're flipping through a dozen web tabs. How does it do all that at once? Well, the magic word, as you might guess, is threads. But here's the kicker, the real secret. These threads, these little digital workers, they're not always working. Not every single second. They take breaks, they wait for each other, they coordinate. And that whole dance is the story we're gonna unravel today.
You know, every single thread has its own little life story. A journey, really, from the moment it's created to the moment it's done. And this journey isn't just one long sprint. It's broken up into these distinct phases, or what Java calls states. And I'm telling you, getting a grip on this life cycle, that's the absolute key to really mastering multi-threading. All right, let's kick things off with the big picture. We're going to start with a quick flyover of a thread's entire life story. So, from beginning to end, you can basically boil a thread's life down to 4 main stages. First, it's born, or what we call new. Then it's ready for action, which is the runnable state. Then comes the interesting part. It gets paused, and we're going to see there are a few ways that can happen. And finally, its work is done and it's terminated. Think of this as our map for the journey ahead.
Okay, let's start at the very beginning. We'll look at the first 2 states, which are pretty straightforward: birth and getting ready for action.
So, first up, the new state. I want you to picture this like a worker who just got hired, right? The contract is signed, they're officially on the payroll, but they haven't actually shown up for their first day yet. In the code world, this means the thread object exists, it's there in memory, but its run method, its actual list of tasks, hasn't been started. It's just waiting to be told to begin.
All right, so once we call that start method on our thread, it moves into the runnable state. Now hang on, because this name is a little misleading. Runnable does not mean it's actually running at this exact moment. What it really means is that it's ready to run. It's in a queue, waiting for its turn to use the processor, the CPU. It's like our new worker has finally arrived at the factory, they've punched their time card, and now they're just standing by, waiting for the supervisor, that's the OS scheduler, to point them to an available machine.
Okay, and this is where the real drama of our story begins. The most complex, and honestly, the most important part of a thread's life isn't when it's running. It's when it has to stop and take a break. So our first kind of pause is called the blocked state. This happens when a thread needs something, a resource, that another thread is already using. It's basically stuck. And you know what? A super simple real-world analogy makes this click instantly. Okay, picture this. You are running late for a super important meeting. You race out to the garage, and the car is gone. Your partner already took it. You are quite literally blocked. You can't go anywhere, you're just stuck there until they bring the car back. In the world of Java, that car is what we call a monitor lock. It's like the car keys. Only one thread can have them at a time. And our poor thread is stuck in the garage because someone else has the keys. So, how does this look in actual code? Well, this happens when a thread tries to run a chunk of code marked as synchronized. If another thread is already in that synchronized section, our thread gets put in the blocked state. It just has to wait outside the door, patiently, or, impatiently, until it's free.
All right, next up we have the waiting state. Now this is totally different from being blocked. Being blocked is like trying to open a locked door. Waiting is, well, it's more like a planned cooperative pause. The thread isn't trying to grab something, it's deliberately pausing, waiting for a specific signal.
And this next analogy just nails the difference. So, you're driving along and a traffic cop pulls you over. You pull over, you stop. You're not blocked by another car, right? You've actively stopped because you're waiting for the cop, who represents another thread, to give you an explicit signal, to wave you on. And until you get that signal, you could be sitting there forever. That's the waiting state. So in our Java code, a thread puts itself into this state by calling a method like object.wait or thread.join. It's basically raising its hand and saying, hey, I'm gonna take a nap right here, don't wake me up until another thread explicitly tells me it's time to go, using something like a notify call.
Okay, our last pause state is timed waiting. And, well, the name pretty much gives it away. It's exactly like the waiting state we just talked about, but with one huge difference. There's a countdown timer.
Let's try a carpooling analogy. You're picking up your neighbor for work. You pull up to their house and you decide, okay, I'll wait, but only for 10 minutes. If they come running out in 5 minutes, awesome, you both leave. But if that 10-minute timer goes off and they're still not there, you're out of there. You leave without them. And that's exactly what timed waiting is. The thread will wake up and get back to work either when it gets that signal from another thread or when its timer hits 0, whichever comes first.
And you see this in code with methods that have a time limit built in. The classic one is thread.sleep 1000, which just tells the thread, hey, go take a nap for 1 second. Or you could have object.wait 5000, which means wait for a signal but give up after 5 seconds. But yeah, sleep is probably the most common way you'll see a thread put into timed waiting.
Okay, so this is a really important point, and it's a classic interview question, by the way. What's the real difference between wait and sleep? Let's break it down. The absolute biggest deal is the lock. When a thread calls wait, it releases any lock it's holding. It's being cooperative, letting other threads have a turn. But when a thread calls sleep, it's selfish. It holds on to all of its locks while it's napping. So wait is for coordinating between threads. It needs a notify to wake up. Sleep is just for hitting the pause button for a bit. It wakes up when the timer is done. Big difference.
All right, we've seen birth, we've seen action, we've seen all the different ways a thread can pause. Now let's go to the end of the line, termination.
And here we are, the final state, terminated. This is the natural end of the road. It means the thread's run method finished all its tasks, from top to bottom. Its job is done, it can clock out, and its story comes to a close. All finished.
So we've just walked through this whole life story, from start to finish. But let's ask the most important question. Why does any of this actually matter when you're writing code? Let's tie it all together.
So let's do a super quick review of the whole journey, right? It's born as new, it gets ready for work as runnable, it then enters that complex dance of being paused, maybe it's blocked waiting for a lock, or it's in a waiting or timed waiting state. And finally, when the work is all done, it becomes terminated. This whole cycle, this journey, is happening thousands, even millions of times inside the apps you use every day.
And this is the big takeaway. A thread isn't just on or off. It's not just running or stopped. It's constantly moving between all these different states. And trust me, understanding this journey is not just some academic exercise. It is absolutely essential for building good software. It's how you debug those nightmare scenarios like deadlocks, how you squeeze every last bit of performance out of your app, and how you build things that can scale without just falling over.
So everything we talked about today was for a thread created in a specific way, by extending the thread class. But that's not the only way to do it. Which leads to a final interesting question. Does this life story change at all if we define a thread's job a different way, using something called the Runnable interface? Well, that's exactly what we're going to tackle in our next explainer. See you then!